Hello and welcome back to Engineering in Motion. In lesson number 2, we built a radar-style obstacle detector using a servo and an ultrasonic sensor. The Python code plotted a sweep line and scattered dots to show objects around the room. Today in lesson number 3, we are going to take that project to the next level. We will add, for example, color coding. Distances will be shown in different colors, so you can instantly see how close an object is. We can also add, a fading trail effect. The older points become more transparent, giving a smooth, professional radar look. We also want, to add, for example, moving average filter, smooth out noisy readings, because in previous lessons we were only reading, the raw signals. And we can also add spike removal filter, it rejects sudden, unrealistic jumps in distance. These are the things that we want, for example, add in our project. These are the kind of techniques used in real-world sensor processing. By the end of this lesson, your radar will be cleaner, more informative, and much more robust. So let's get started. About the hardware is exactly the same as lesson number 2. We have an ultrasonic sensor. The trick pin connects on pin number 9 on our Arduino board, and the echo pin on pin number 10. The servo is connected to pin number 11, and we just have the same power connections. The Arduino code is also unchanged from lesson 2. We don't change anything in our Arduino code. Here, as you can see, this is our Arduino code from the previous lesson. We don't need to change anything here. It sweeps, the servo from 0 to 180 degrees and back, reading the distance at each angle and sending, angle and distance over serial at 115200 baud. Okay. This baud rate. Okay, so we don't need to just do anything here in Arduino IDE. Okay, we can go directly and start our project in our Python environment. Okay, so let's go and do it. So in order to do that, I will open the previous lesson code. Lesson number 1. So this is the code for lesson number 1. Okay, and for today's lesson, I'm gonna create a new file. Okay, I'm gonna call it, for example, radar part2.py. Okay, all right. So this is for today's project, and this is for the lesson number 2 project. So now I can easily select all. I can copy the lesson number 2's code, and I come to today's file, and I'm going to paste it here. Okay, so because we will just modify today's code, and if we need to add something, we will add it here, and if we don't need something, we can easily remove it. It's much easier than just doing it from scratch. Okay, so let's start from our imports from the libraries. We need we need the serial, we need the matplotlib, we need the collection numpy as np, and we need today we have to import our deck. I can say from collections import deck. Okay, so from collections import deck, right? Why I added this deck? This deck stands for double-ended queue. You already know, is perfect for our moving average and data history, because it automatically discards old items when we set, for example, a maximum length to a limit. Okay, next line, we just we connected our Python to our Arduino IDE. Okay, so we said ser serial.serial cam9. But be careful, guys. Remember to change this port number. Maybe yours is different than mine. Be careful. And after that I said plt.ion figure. We created the figure. We just created the polar axis. We don't need to change anything here. Now let's go to the the initial condition here. About the initial condition, I just want let's just delete these two variables that we created in the last lesson, because we want to just create everything from scratch. I mean the initial conditions, because we have so many things here. So it's better to just do it from scratch, and we don't need these two empty variables for today's project, and we're going to replace it with other things. So the first variable that we want, I want to say, for example, I'm going to call it like max point. Okay, but what is this max point? This max points, it determines how many of the most recent sensor readings we keep on the screen at once. So for example, let's say 50. It depends on you. Okay, you can say, for example, 100, you can say 80, 90, 70, whatever you want. I say 50. Here I store the last 50 angle distance pairs. So when a new reading arrives, the oldest one drops off automatically, because we are using a deck with a maximum length later in our while loop. Okay, but be careful, guys. When I said these are the initial condition, the parameters. So as I told you, in the previous lesson, we will update these variables later in our while loop, in our main loop. Okay, so now I said 50. So later in the main loop, we will update our samples or our data. So it means we will keep only the last 50 samples at our screen, and the oldest one will just get removed automatically by the deck library that we imported at top. Okay, the next parameter is about our filter system. There's a term, it's called moving average. Moving average is a simple way to smooth out short-term fluctuations in a data stream. I mean, instead of, for example, using each raw sensor reading directly, you take the average of the last n readings. For example, like it depends on you, 5, 10, 15, it depends on your sensor. So you take the average of the last n readings and use that average. So the moving average window, it's a term, moving average window. It's often called like window size or filter order. So this is a number, I mean n, of the past readings that you included in average. Okay, so now I want to just create that n, that number. For example, I say n. Let's say it in, write it in capital. So I'm going to say n equal, I will want, for example, to keep, for example, last 5 raw distance. Okay, I'm going to say 5. But maybe you say why we chose 5. It just depends on your sensor. If you have a very noisy sensor, you can just keep, for example, 10 or 15. But for our project, I think the last 5 raw distance reading is okay, it's enough. So after that, we compute the average of those 5 value and use that average for plotting. Okay, so instead of using raw data, we will just filter the last 5 raw data, and then we will use that filtered data. Okay, so the next parameter, I want to call it like, let's say, max jump. Okay, but what is this max jump? This max jump, I say, for example, I have to give it again a number. Let's say, for example, I give it 50. But what is this? What is this max jump? Max jump, this is the maximum allowed change in distance, I mean in centimeters, between 2 consecutive readings. If the new raw distance differs from the previous valid distance by more than 50 centimeters, we assume it's a spike. Okay, it means, we assume it's a noise or error, and we replace it with the previous distance. This filter, this filter ignores sudden unrealistic jumps. You may need to adjust this value, depending on how fast your objects move and how noisy your sensor is. So again, one more time, this is also depends on you. You have to just change it, and you have to just come and try to see which number is perfect for your sensor. I think 50 is enough, and it's okay. So we will just, when we run the program, we can see the effect, we can see the result, and if it was something wrong, we can just come and change these numbers. Okay, but now it's time, for example, to use our deck library, because I don't want to just keep all data. Okay, after I just filtered the last 5 raw data, how many of the data I want to see on my screen, because as I told you, I don't want to flood my screen with all data. So I want to just delete the old ones. Okay, so here I have to create another variable, like for example, let's call it distance buffer. So distance buffer, this is another variable, and now I have to just use my deck library. So I'm gonna say deck. Okay, deck. If you can remember how we were using, now I have to say max length. But what is this max length? What I should pass it? I should pass it this n. Okay, the n, the variables, the filtered raw data that I used. Okay, so I pass it n. So this creates a double-ended queue, I mean deck, that will hold exactly the last n raw distance values. When we open a new value and the deck already has n items, the oldest one is automatically discarded. So this is perfect for moving average, because we always have the most recent window of data. Okay, so this is it. What else we need to define here? We're gonna now we have to just if you can remember, we deleted 2 empty variables before I started creating them. It was angle and distance. So now I want to just store the previous valid distance after spike filtering. Okay, let's say for example, let's call it last distance. Okay, so last distance, but initially it's none. So initially it's none because there is no previous reading. Okay, so initially we pass it none because at the beginning there is no any previous reading. So in the main loop we will check if last distance is not none before comparing the jump. After we process a reading, we update the last distance to the possible corrected distance. Okay, that's it. So this is for the distance. One more thing, guys, now I have to say how many of the data, for example, I have angles and distance, but how many of these angles and distance I want to see, for example, before the oldest one remove. Now this time I have to use again my deck library. Okay, so I'm gonna start with the angles, for example. So I'm gonna say angles, and I'm gonna say deck. Okay, deck, and I'm gonna say max length. But what is the max length? And now I have to pass it this max point. Okay, this is the 50. Okay, the max point that we defined above. So now I'm gonna pass it max point. Okay, max point, and I'm gonna do the same thing for the distance. Okay, so I'm gonna say distances. Okay, distances, and I'm gonna say deck. Okay, max length. Again, I'm gonna say max point. Okay, so these are the variables, the parameters that we had to define, at the beginning. I don't think that anything else left. That's enough. Now I think we can just go directly and just update our main loop. Okay, so in the main loop If you can remember, I said, for example, we want to also change the color of the the objects that we see, depends on the distance that they are. So I can do all these things in our main loop. The color. Oh yes, it's good that I reminded about the color, guys, because we want to change the color of the objects. So I forgot before the main loop, we have to define a function to change the colors. Okay, exactly like the LEDs, if you can remember. I forgot about that. Thankfully I just remembered now before everything. Let's just first define a function to differ the colors, to just that we can change the color of our object. I'm gonna say def get color. Okay, get color. But now I'm gonna pass it dist. Okay, the argument I passed the dist argument. It's just a helper function, like the if you can remember, if the SMD or LED, the RGB that we had. So now here inside the function, I'm going to use if condition. I'm going to say if dist, for example, let's say if it's smaller than 50. Okay, I think it's okay if it's smaller than 50. It depends on you guys. These are the distance. I said if it's less than 50, then for example, we want to see the objects in red. So I'm going to say return. Now I'm going to say red. And I'm going to say elif if dist, for example, if elif dist, let's say this time if it's smaller than 120. This is just a number that I chose. Maybe you choose different numbers. Now I'm going to say return black. Okay, return black. And just one more thing, I don't want to use any more colors, so else I'm going to say if nothing, or if it's not 50 and if it's not 120, then we will return like green. Okay, so this is the helper function that returns a color based on distance. Red for distance less than 50 centimeters. It means danger. It means that the object is very close. And otherwise it will be black for distance between 50 and 120 centimeter. It means that it will be moderate. And it will be green for distances 120 centimeter and above. It means safe, far away. So you can adjust, as I told you, you can adjust these thresholds, these numbers, to match your environment. Color coding makes the radar much more intuitive. You can glance at the screen and instantly know where the closest obstacles are. Okay, so we finished creating our function. Now it's time to go and update our main loop. Nothing else left outside of the main loop. Let's go to our main loop. So inside of the main loop, we first clear the serial buffer with this line, and then we read the line. And we split it into angle and distance. We split it after we read it from our Arduino IDE. After that, we will split it, okay, into the angle and distance, and then we convert the angle to the radians by this line, and with the help of NumPy library. And the distance distance will be float. Okay, so this is we don't need to change anything here. But from here, these two lines. Okay, now let's just delete these two lines for now. Okay, after this, let's just create this spike removal. Spike removal prevents a signal, a bad reading from ruining the display, because the ultrasonic sensors can sometimes give wild values due to electrical noise or acoustic interference. So it may just the sensor may become some noisy, and you may become some you may just see some weird data on your screen. So this is how the spike removal do for us. So we check if we have a previous valid distance. Let's just write it down so you understand better. So I'm gonna start with an if condition, I'm gonna say if. So now I want to say if we have a previous valid distance. Okay, how I can say that? I can say if last distance, okay, the variable that I created above, if you can remember, if last distance is not none, okay, so if last distance is not none, it means that I check that we have a previous valid distance, and I'm gonna now I have to check the absolute difference between the new distance and the old one. Okay, so I'm gonna say a and abs. Abs stand for absolute, so absolute, I'm gonna say distance minus last distance. Okay, so here the absolute difference, we calculated the absolute difference between the new distance and the old one. That so why I want to calculate this? I want to compare it. Now I say to compare it to what? I'm gonna say max jump. Okay, so we calculated the absolute difference between the new distance and the old one that exceeds max jump, like 50 centimeter, or whatever you say. So now what we want to do now we assume that this is a spike. So we assume that this condition, we assume that this is the spike. So what we're gonna do, instead of just using the bad value, we replace it with the previous valid distance. Okay, so one more time. Now instead of using this spike, we replace it with the previous valid distance. How we can do that? I'm gonna say distance. Now I'm gonna say last distance. Okay, then after that, let's just update the last distance to the possible filtered distance for the next iteration. Okay, so how we can update it? I can say last distance. Now I'm gonna say last distance equal to distance. Okay, so we update the last distance to the possible filtered distance for the next iteration. So with these three lines, this simple filter works very well for slow moving objects. So if the sensor sees a jump from 30 centimeter to, like, for example, 200 centimeter in one step, because it's not possible, guys, it's not possible that, for example, sensor sense an object now, for example, it's in 20 centimeter, but suddenly it changed to, for example, like 200 centimeters. So it's not possible. It means that it's a spike, it's an error, it's a noise. So it's almost certainly an error, so we ignore it. This is all what we did here with this if condition. So far we just created the spike. Okay, so by just detecting the spike is not enough. We have to just update our program, update our screen. So how I can do that? Now I want to add this the possible spike corrected distance that I detected to the distance buffer deck, to the one that I created above. How I can append? I can use the append built-in function again. Okay, so let's say call our first our variable that we created above. I said distance buffer. Now I'm going to say dot append. So what I will append to this one, I will append to it this distance, this created this distance that I just detected that it was a spike and we corrected it. Okay, so I'm going to say distance. Okay, so what did we do here? We just add the possible spike corrected distance to the distance buffer deck. This distance buffer deck holds the last n values. I mean, our n is 5. Then now what I want to do, what I have to do now, I have to just compute the average of those values, the values that I have. But how I can do that? Now I can use the the mean built-in function, but this is the built-in function in our NumPy library. Okay, But how I can use the numpy, our mean built-in function? It's very easy. Let's just create like a new variable and put it the new variable. I'm gonna call it like avg distance. Avg distance, like, you know, I mean, for example, it's average distance. So average. First, I'm gonna call my library. I'm gonna say np.now. I'm gonna use the built-in function. It's called mean. So mean, what I want to use, I'm going to say distance, the one that I append here. You know, I append the distance to this one. So I'm going to say distance buffer. So average distance equal to np, that mean this distance buffer. But maybe you ask, you know, why we just we take the why we use the mean. Mean, I mean, as I told you, it means, you know, average. You know, it takes the average, you know, amount. That's what it means, you know, the mean. So why average? You know, ultrasonic sensors have small random, you know, variations in their readings. So averaging smooths out, you know, these fluctuations, giving a more stable and reliable value. So the downside is a slight increase in response time, but with the n that we said, we say 5, it's barely, you know, noticeable. So you have a smooth, you know, data in your screen, in our radar, and this is, you know, a part of our filtration. This mean, so this average. We take the average of our data and then we see it in our radar scope. And now it's time to update, you know, the angles and distances decks that we created in our here. See, in our initial condition, these two variables, okay, angles and distances. Now it's time to just append, you know, to these histories. So how I can do that? I can say after these two lines I created just now, okay. So now I can say angles dot, again use append built-in function. So angles that append, what I want to append to the angles, I want to append angle to it, okay. So I append angle, and we're gonna do exactly the same thing for the distance. So I'm gonna say distances dot append. What I want to append to the distances, this time I want to append to it the average distance, you know, this average, this mean value, I want to append to distance. So I'm going to say avg distance, okay. So now I updated my history, okay. I'm gonna just I can delete this, you know, because this is the way that we were manually, you know, deleting the old data, but here we are using the deck library, the deck module, so we don't need it. Okay, now let's go to our, you know, plot preparation and drawing. So we have at the beginning we have ax.clear. So this ax.clear, we clear the previous frame, and after that we just reset the polar coordinate system, you know, I mean 0 at north by this line, and, you know, clockwise direction by this line, okay. And the radial limit, you know, from 0 to like you know, I think 200, it was too big, it was a lot. We don't need, you know, 200. Let's just try 100 for today's project, guys, and see, we will see the result when you run the program. It doesn't matter, you know, you can just keep it 200, it's completely okay. But I just say, let's say 100. I think it will be just, you know, more, because, you know, the room is the environment that I am here now, I am in, it's small, and we don't need, you know, to see, for example, like to 200. 100 is 1 meter, I mean, is enough, okay. So I changed, you know, the limit to 100 centimeter here, because as I told you, we are focusing on close objects, but you can adjust it, you know, the way that you want. I told you. Now we come to the sweep line. You know, the sweep line now, you know, goes from the center, from 0, okay, all the way to the outer edge. Let's, you know, it's if you can remember, the last session, it was, I said from 0 to distance. So the length of the needle was changing, according to the object. But let's today make it, for example, constant. I think, it would be better, okay? So instead of saying from 0 to the distance, I'm going to say from 0 to 100. I mean, all the way to the outer edge of our scope, okay? I mean, at the current angle. So this makes, the radar look more complete, because real radars, they have, they have a needle, so the length of the needle doesn't change, according to the object. It has a constant, length, and then it will just depends where is the object. It will show the object. So this is, it makes our radar, our scope, much more realistic, okay? And the line width is 2. Okay, so let's, guys, I think, for today, instead of just seeing, like a random, for example, the red, or a random number, let's just see, for example, tell the program this time I want to see, for example, the color, let's see, cyan. Okay, so the needle today, I want to see it in cyan. It depends, it's optional, guys. It's completely optional, okay? Maybe you want to see it by default color, or you want another color. Or you can just easily just ignore this color, this section. I just want to just show you that, in Python, you can do so many other things that you want, okay? So that's it. That's for the needle, okay? About these scalars. These scalars, we will use it, in our because we have to create for loop, because we want to see the scalars in different colors. So we can't just use it directly in our for loop. We have to put in our main loop. We have to put it in a for loop. So now, in order to do that, I'm going to just delete it from here, or I'm going to cut it, because I will paste it later in our for loop. So now we have to detect, the object with fading effect, okay? Because you don't want, for example, we want to see after, some time, when the object goes away. For example, the scatter will just fade away slowly, not just one time, not just like 0 or 1. We want to see, for example, the fade effect on the scatters. This for loop that we want to create here now, I think, this is the most sophisticated part of the code in today's lesson. Okay, so let's just start creating the for loop step by step, and I will explain it to you. Okay, so now I'm going to say for I just, it doesn't mean just, any specific, just, it doesn't have any specific meaning. I just say for I, because I want to just mention, to the distance and the angles that we have. So I'm going to say for I, but after this I, as I told you, today we have, angles and distance, okay? So we have two variables. I mean, in other words, we have two loop variable. I'm going to call them A and B. So, okay. So these A and B, they unpack, each pair, because we have, as I told you, angle and distance, and each angle and this angle and distance, they have pair, okay? The A and B, they unpack each pair into A stands for example, angle, and D, D, I said B, like D, A and D, okay, so D. So D stands for distance, A angle, D distance, okay? But after that, I'm going to say, okay, let's just go ahead. When we just write the other part of the for loop, you will understand why we have to use these A and D, and I will explain it more. So I'm going to say for I, A and D, just remember this A for angle and D for distance. That's why I choose A and D. So for I, A and D, okay. Now I want to say enumerate, okay, enumerate, And inside of the enumerate, again, I'm going to use another function. It's called zip. Today, we are going to use a new built-in function. It's called zip. And inside this, I'm going to pass it two, arguments. So angles and distances. Angles and distances and column. Okay. So let me explain to you what this, zip, angles, and distance mean. The zip function pairs, each angle with its corresponding distance. For example, if angles, they are 0.1, 0.2, 0.3, and distances are, for example, like 30, 45, 60, then the zip function, it gives us a pairs. For example, it will pair, the first, the list of the angles. For example, the first argument of the list in the first argument in the list of angles with the first argument in the list of distance. For example, it will give us like 0.1 with 30, 0.2 with 45, 0.3 with 60. Okay. And this enumerate, what about this enumerate? Enumerate, adds a counter to each pair. It returns, index pair. So for, 3 points that I gave you as an example, we get like I equal to 0, pair 0.13. For example, I equal 0, first pair. I equal 1, the second pair. I equal 2, the third pair, and so on. Okay. And these A and D, as I told you, we unpack each pair into A stand for angle and D stand for distance. This is why we have to use A and D. Okay. We unpack each pair into this A and D. Okay. So in the next line, we have to just calculate the transparency level. If you can remember, in order to just change the transparency, we were using something called alpha. Okay, alpha. So alpha, I'm going to say alpha equal to, so I can say here, I have to write a formula here, guys, but don't worry, it's not that hard at all. So I'm going to say I plus 1. Okay, so after that, I'm going to divide it by length of angles. So length of angles. Don't worry, guys, at all. It's very easy. This length angles is the current number of points that's stored, up to max point that we defined above. Okay. This is about the length angles. And this formula, this line, this calculates the transparency level. So alpha ranges from 0, it means completely transparent, to 1, that means completely opaque. Okay. So if we want to let's just put some number here and give you an example. So for the oldest point, for example, for the I equals 0, the formula will be like this. Sorry, guys. It will be 0 plus 1 divided by length. Okay. And it will be equal to 1 over length. It means that very small, so very transparent. And let's try for the newest point. For the newest point, let's say, for example, I equal to length minus 1. So the formula will be like alpha equal to length over length, it will be 1. It means fully opaque. So 1 over 1 means 1. Okay. It means that fully opaque. So older points are drawn with high transparency, newer points are solid. Okay. This creates a fading trail as the servo sweep. But there's also another alternative approach. You can use a color map. You could use, for example, also achieve a similar effect by using a color map, where the color intensity decreases with age, but the alpha method is simple and effective. It's not hard at all, guys. Maybe it's a little bit, when you look at it, when you look at this formula and this, oh, sorry, it's just I made a mistake for I, A, and D in enumerate. I made a mistake. Sorry, guys. Be very careful. In you have to put an in here. Okay, so. Yeah, I was telling you, maybe at the beginning when you look at it, you say, oh, it's very sophisticated, it's very complicated, and you can't understand. But it's not like that. If you just pause the video and think about it a little bit, you will come to this conclusion that it's not that hard at all. And if you watch the video 2 or 3 times, only this part, and you just, analyze it in your mind with yourself, you see that it's not hard at all. So we used a new built-in function, this zip and I told you what does this zip do here. Okay, and we used this enumerate before in previous lessons. So this zip, as I told you, it pairs each angle with its corresponding distance. And this formula, it is for the fading event. Okay, and after that, we easily, if you can remember, we cut a line here. So now I'm gonna oh, sorry, I copied something else, so I lost it. So let's just, it doesn't matter, it's not that hard at all. So let's just write it down again. So I'm gonna say ax dot scatter. Okay, ax dot scatter, open and close parentheses. Now I'm gonna pass it a, this a and d that I created above. So ax dot scatter a and d. Okay, a and d. Now let's give it the size. For example, let's say I think 20 is good. Okay, 20 is okay. I don't know, I forgot what was the last lesson size. I think it was 20. I don't know, but we will check when we run the program. So size 20. Oh, okay, now about the color. Now it's time to use the function, the helper function that we created above. So I'm gonna say C. C stands for color. Okay, C equal, now I'm gonna call my function. It's called get color. Okay, get color. And I'm gonna pass it d here. Okay, d and alpha. Okay, and now it's time to say alpha equal to alpha. All right, so this is it. We don't have to do anything else here, guys. Okay, just one more thing about this formula. Okay, it's completely adjustable. You can adjust the fading curve by changing the alpha formula here. Okay, this formula, for example, you can say I plus 1, and before this division you can say, for example, time 2. Okay, it would make the fade faster, or you can make it slower by using sqrt, square root. Okay, it depends on you, different kind of formulas you can use, but this is what I do, because I tried to keep it as much as possible simple. So that's why I don't use anything else, and I didn't add anything else here. After that, we don't change this pause. Okay, to just allow the plot to refresh, and nothing else left, guys. I think everything else fine, and we don't need to change anything else. Now it's time to go and just run the program and see what's gonna happen. Okay, so in order to run the program, I'm gonna start with the Arduino IDE. I'm gonna just upload the code into my Arduino board. I just pressed the upload button. Okay, so because we didn't change anything, we shouldn't have any problem. Now I go to our Python environment. I run the program. Okay, guys, see, it's perfect. Let me just make it a little bit smaller so you can see everything clearly. Okay, all right, so let me just, I don't know why. Oh, okay, now it's just okay. So see, as you can see here, you can see the objects, you can see the needle. Now it's a constant size, it's the constant length, it doesn't change. And now you can see, you know, the fade event. See the objects, they are fading slowly. Just you know, let's just go and change that max length, you know, variable that we created, this one, this max point. Okay, I think instead of 50, let's put it on 25. Let's run the program one more time. That's great, guys. Yes, see, now you can see the fade event, you know, much more clearly. Okay, let me make it a little bit. Okay, see, now as you can see, you know, here the old data, you know, the old scatters, they are fading away slowly. And let me just, for example, put my hand in front of the sensor and see what's gonna happen. Yes, see guys, see these points, it means that my hand, it detects my hand. See, yes, again here, see. Now let me just remove my hands and see if these scatters fade. Yes, see, these scatters, they are fading away. That's great. Let me just try one more time, guys. I put my hands in front of the sensor, like here. Yes, see these points. These points means that it detects my hands, you know, here. Okay, that's great, guys. So as you can see, you know, our radar, the scope is, you know, much more, you know, resemble to the, you know, real radars. But, you know, don't worry, in the future lessons we can do, you know, much more things and make it much more realistic. But for here, as you can see, everything works perfectly, and you know, the colors are different. And if you want, as I told you, you can go and change, you know, the thresholds in the program, you know, the size of the scatters, and you know, other things, the line width of this of our needle, or you know, the thresholds of, you know, the scatters. Everything you want, you can go and change. And hope you like this lesson, guys. Please let me know if you have any question or if you have any doubt about any part of the program. And hope you liked this lesson, and see you in lesson number 4.